So this is Shankar. I'm having total 15 plus years of experience in IT. So I started myself as a remote data center engineer, and I moved to virtualization, cloud, DevOps. Currently, I'm working as a lead DevOps engineer who actually manages the cloud environment, DevOps environment, as well as containers and the automations mainly infrastructure as code, different roles, different tool sets came into my life actually. So that's about me. So let us today topic which I'm going to cover is introduction to the cloud. So for example, Azure cloud, but we are going to cover other two clouds as well. But before we proceed directly to the cloud, so I would like to give a few examples, real-time examples. These days, how we are traveling, right? For example, I want to go different country, different state, different village, or different city, right? How we go? Generally, we having a habit that we generally open the mobile and book the ticket, maybe IRCTC or Go Ibibo or any other, even our red bus, this that everything holding, even government buses they having their own application to book the tickets, right? So simply we open the mobile, or the old people, for example, they open the laptop and they access the same application, maybe Go Ibibo or IRCTC, they open in their laptop and the book tickets. Simple. But see, either mobile or laptop, they're opening same application belongs to same organization. If you take IRCTC, that's a government running organization, right? So we are going to connect to that server. We are booking the tickets. Either my point here is either laptop or mobile. We are connecting to same server, but once we booked, we'll get the some confirmation message. We'll get the seat and we'll book so and so date. Will return back. So that's about travel. What about entertainment? Entertainment we do a lot, right? We play games on mobile or laptop again, and we used to book the tickets for movies, watch videos in YouTube, and many more social media apps that's what our daily routine, right? So also we watch emails, whether any new email related to offer, related to interview, anything it might be. We use document application for to prepare our resume and to showcase our skill, and we take pictures using other app, and when we share that, we connect with the friends with the different social media platform applications, right? All this again, or laptop, or either laptop or mobile. So again, we are doing the same. Any device, we are taking control of a device and we are using the application. Even entertainment source, we are relying on applications, either desktop applications or mobile applications, right? So first of all, let us understand what is an application. Application is nothing but it's a program where installed in a laptop or mobile. Pretty much simple. So just now we discussed about IRCTC, Go Ibibo, Redbus, and many more applications. Even WhatsApp, ShareChat, whatever. Different application related to different activities, and we are consuming. So an application, it's referred to a program or application software, is a computer software package that platforms a specific function directly or indirectly. So an application can be self-contained or group of programs. It may be single program or multiple programs. It's a simple, an application in generic words is to do certain job. For example, WhatsApp. The, what's the purpose of that? To send a message, video call, audio call, receive the message, getting the audio call, getting the video call, and status this, that, DP, everything we change, right? Those are the functionalities. of that particular application. So again here, if you speak about application, there are two different versions of applications. Not the version, two different applications are there. For example, mobile application, desktop application. So two different, both are not really same. Even in the mobile application, you have to have the Windows applications, Android application, and iOS application, right? Three different types again, even in the mobile application. So why we are concentrating this? Because I will take you to the journey right from application to the cloud. If you seriously follow this particular track, you will understand what exactly happening outside, where you need to focus, what will be your further steps towards. Simple. Try to understand. Just bear this 1 hour or 1 hour time, and you will understand what happening outside. We are hearing software engineer, right? What they're doing, right? So everyone really not developing the code. Everyone really not writing the code in the .NET, Python, Java, Ruby, whatever, right? So let us understand. So requirements for an application. If you want to run an application, you need an operating system. So for an application, if you take the mobile app, you need a mobile, right? You need some memory in it, CPU in it, operating system like Android, iOS is needed there. So if you speak about desktop operating systems, you need the operating system and the physical hardware, whatever, literally software and hardware combination, literally. So what is operating system? We just mentioned operating system, right? So OS is nothing but a mediator to the hardware and user who actually giving the input. So it's a mediator between the input devices and output devices, CPU, all this. Simple. That's what operating system. Your mobile having an Android operating system or iOS operating system. Your laptop literally having a Windows operating system, Linux operating system, all that different, right? So this is what operating system simply there to run your applications, whatever the application. If you take calculator, if you take the MS Word or Paint, Notepad plus, right? Visual Studio Code, anything. These are applications actually runs on top of operating system, and you will able to consume that. So far we discussed about the normal operating systems, right? For example, your mobile, my laptop. But there is another world which we need to really think about. So operating system in this particular scenario, in my previous example, this example, I'm really not meant of your mobile or my laptop. No, there is operating system. Two different kinds of operating systems are available. It's not about Windows Linux. It's about server operating system and desktop operating system. Desktop operating system, for example, Windows 10, Windows 11, right? All that, Mac OS, whatever. And server operating system is about Windows 2022, 2019, 2024, Linux, Fedora, Ubuntu. Yeah, Linux in the sense Red Hat Enterprise Linux, CentOS. All these are server operating systems. Why we need server operating system? First of all, server operating system to manage very huge amount of compute. For example, memory, CPU, hardware devices, input devices, and the internet which is going to access is very huge, right? So if you take your computer, maybe laptop, you might have maximum 16 GB or 32 GB. If your system is very high end, you will have 32 GB of memory. But server operating system is about terabytes of GB only for memory. If you take your hard disk, maybe SSD or HDD, right? Standard disk drive or a solid state disk drive, anything it might be. Solid, you will get better performance. You will have some 1 TB, 2 TB maximum. Generally, you won't have 2 TB. I'm saying, right? So maximum you can have for a very good laptop, you can have 2 TB, for example. But hundreds of terabytes will be attached to your server operating system. So that's why companies built, if you want to run a server, you have to have server operating system. If you're an end user, like me, like you, we generally use the desktop operating system line, for example, Windows 10, Windows 11, or other operating systems. So now we are concentrating on server operating system, not your desktop or mobile operating systems. Okay, let us go one step ahead. So, as we just discussed, terabytes of memory, terabytes of data, very huge bandwidth network, all that will be given to the operating system. So where that server operating system resides in, that server operating system resides in a server hardware. You can see this. This is a blade server. What we call is a blade server. It contains the CPU, it contains the memory, and it contains all supported hardware devices, whatever. So server operating system runs on a server hardware. Maybe this is blade server and rack mount servers also there. There are two different rack mount and blade. Blade is very latest technology, and this is what most of our applications, whatever you access outside, that is where it is running actually. So okay, we just told blade server. Okay, how that fits in a rack. If you see on the left hand side, your server with CPU, whatever RAM, disk exist in that particular blade server. It goes to the rack, and inside the rack, this is just one piece. If you see, there are n number of pieces on the rack. So 40 to 80 servers, right, will fit in that particular rack. If you go one step right, cluster. You can see a cluster. Cluster is combination of racks. Each rack have 40 to 80 servers, and a cluster is n number of this particular racks. So a server sits in a rack. If you feel bored, or if you think I'm taking to different world, ignore it. Just buy this 1 hour for me. So you'll understand finally. So if something really not understand, nothing to worry. Just consider this is a movie. Okay. So okay. So each blade sits in a rack. Each rack goes to a cluster, and this entire place is called a data center, DC. So if you might heard very recently, right? Vizag got the Google data center, very large equipment they are building. This is what? This kind of data center they are building. So the warehouse, Gaint warehouse means very big warehouse. What it contains is, we just looked in rack servers, storage arrays, cooling infrastructure, power converters, backup generators, right, etc., 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 cables, right, all that at the back end I'll show you. So this is the data center. What we discussed earlier, there is an application irctc.com to book your tickets that sits in a blade, that again sits in a rack. That rack is in a data center within a cluster. That cluster sits in a data center. So this is where we are accessing any, you name any application, you name any application that have to be inside one of data center, whether it is public related server, or the private cloud or public cloud, private cloud or on-premises, anything. In any situation, your application have to be in this kind of data center, not the same actually. Each and every company, organization will have their own set of hardwares, and that is called data center. So their application will be hosted. If you take banking application, ICICI, HDFC, right, Axis, anything, that also goes to this kind of data center. So these are a few data center examples. If you see, some are in the fields, some are in the ocean. Very down one, you see, that is related to Microsoft, right? Microsoft data center, Microsoft Azure data center, hosted in a sea. So like this, a very huge infrastructure will be there for your application. So why we are here? First of all, we are here to host. I mean, we are not the developers. First of all, in my perspective, I'm speaking today, we are going to maintain the application, but not the developer. We don't need to know any single line of the code. We are here to safeguard our application, right? You know, how many layers it's been, right from the blade to the data center. We are having different level of responsibilities to care our application. If this server goes down, how I can up my application in different server, right? There are many strategies which we need to plan, which we need to configure, which we need to monitor. Have you ever seen so and so application? For example, banking application is down. Very rare. Maybe in a year, you could see 1 minute or 2 minutes in a year, right? So we have, I mean, each and every application plans high availability as well. If this goes down, where my application will be accessed? Because, for example, Amazon is down, right? What happens to the business? Amazon, whatever the Amazon orders, you won't wait for that application to be come after a week. No, simply you need your own needs, maybe urgent, maybe not, right? You simply open whatever the opponent, competitor, Flipkart, so and so, you simply open that, book your application, sorry, book your order. So business, everything here matter for business. So each and every organization, they maintain their application, business or even normal application, they host in highly available conditions. If one place gone, your application will be available from the different place. I'll explain in future slides. But this is how your data center will be located like this. So we'll go to the virtualization. So far, we looked into hardware, right? This is hardware, nothing but hardware. So very first concept is virtualization. Virtualization is nothing but, it's the same. If you take previous example, this example, on a blade server, what we are doing, we may install Linux or Windows operating system. On top of that, we install our application, maybe irctc.com, and through internet service provider, Airtel, Jio, whatever, at the data center level, by consuming that services, we expose our service to the internet. irctc.com, that's how it is accessible to you. The application being exposed to internet, and you're able to access that. So this is what physical environment, right? If you come to the virtualization, the physical server, the black box at the down as it is, right? That is what blade server. And on top of that, traditional architecture means the physical server, blade server, whatever I mentioned so far. Blade server is there. One operating system like Windows or Linux. On top of that, only one application I'm able to install, configure, and I expose that to internet, and we are accessing that. So very next thing is virtualization. So if you see virtualization on the right hand side, blade server as it is. On top of that, what we are installing, there is a name, VMware. So that is virtualization software. In virtualization, there are two powerful solutions available. That is VMware from EMC, and other one is Hyper-V, is Windows one. I mean Microsoft one. Microsoft Hyper-V and VMware. VMware ESXi, ESX. There are many. So these two are the key players in virtualization. So, for example, Hyper-V or VMware, we are not going to worry about it. That is not our duty to learn, first of all, right? So, on top of the physical server, we will have Hyper-V or VMware is a virtualization software which we'll install. On top of that, if you see, there are different operating systems I have installed, different applications are available. Same hardware, 6 different applications are available, right? For example, redbus.com, for example, goibibo.com. Generally, we won't install multiple organizations, right? A organization, their organization related applications will be hosted. What we are saving here, we are saving a lot of space, a lot of hardware, a lot of maintenance, a lot of power backup, a lot of cooling equipment. There are many things we are really saving by following virtualization. So very first revolution, what I say is virtualization. Virtualization, when we start virtualization about 12 years, so those days, everywhere virtualization, virtualization, virtualization. We learned like anything, and the job opportunities are a lot. Those times, those. So that's what the benefit of virtualization is. Pretty much simple. You can save the cost. You can host multiple applications, multiple operating. It's not about only Windows. You can host Windows operating system, Linux operating system. It's your wish, your choice. Each and every operating system is identical. So done. So this is what virtualization is here to save the cost, save the space, save the hardware, save the maintenance, everything. One more step towards is cloud computing. So if somebody want to speak, somebody want to stop me, please feel free. I don't mind. Okay. So very next thing is cloud computing. This is another revolution, you know. So cloud computing, the same data center, physical data center, whatever the place, it is as it is. One more layer added, virtualization also there. Now, cloud computing, it's like, let us see the definition. Cloud computing is a term referred to storing and accessing of data over internet. This is very much important word. Internet is very much important. Without internet, you can't access your cloud resources. Pretty much simple. Without internet, you can't expose your application, you can't access your application, even you can't connect to your resources without internet. Very basic requirement for cloud computing is internet. Nowadays, that's not a challenge. Each and every device is connected with internet. So it does not store any data on the hard disk of your personal computer. In cloud computing, you access data from a remote server. Pretty much simple. So, for example, here, I do have a cloud portal. For example, Azure Cloud. I'll show you, even I'll give you the demo. So, I'm trying to access my resources in Azure Cloud. Do I need to store anything? No. Everything stored in cloud itself. My laptop, just a mediator. It's not going to do anything. I'm going to connect to my cloud and I'm going to access the data there itself, store the data there itself. Very much simple. So, another way to understand the cloud computing, on-demand delivery of computing resources over the internet. Again, same word, over the internet. So, on demand is nothing but, for example, today I want some 10 application I want to build. maybe application 1, application 2, application 3, and application 10. I want to install 10 different applications, one for the gaming, one for the ticket booking, one for the entertainment, or anything, streaming, anything that matter. So on demand is nothing but, if you want to create your application now, okay, go create, deploy, expose, use it. For example, after 10 days, you don't want 5 different applications on that 10. No problem. Just delete whatever the service you don't want on that minute itself. So what we need to pay, for example, if I'm a consumer of cloud computing, I created 10 applications, 1 month gone. Very first, after 30 days, I removed 5 applications. Only 5 applications are very hit and it is growing like anything. 5 business are growing like anything, but other 5 is flat. So I need to remove that 5 different applications. I need to continue other 5. So what I need to pay for 10 applications first month. Next month onwards, because you deleted those other 5 applications, next month onwards, your billing is about only 5 applications. So on demand, even not about month, minute-based billing. For example, if I created an application now, after 3 minutes I deleted, no problem. Your billing is only for the 3 minutes. See, but if you compare with the legacy, old tradition, to procure a blade, for example, 10 blades, if I need to procure, I need to order 3 months back and it will come after 3 months. In configuration, initial configuration like cabling, all required ports and required power cables, all that configuration data center team will take like 10 days, gone. And installation team, like tools team, operating system team, everyone configures again 1 week, gone. And your application will be accessed. If business is flat for that particular 5 applications, again you have to roll back, delete, and you have to sell this to vendor, but you have to pay a lot of money. But here with cloud, pretty much simple, minute based. If you're using 1 minute, pay only 1 minute. You don't need to pay advance like last time. You don't need to pay for the hardware. You don't need to pay anything. Only thing is whatever you bill, pay and go, done. Even, for example, you decommission each and every application, done, your billing is zero. You don't need to pay anything. Even I'm maintaining my Azure cloud. I'm having my dedicated Azure cloud, which I'm paying maybe 10 rupees, 20 rupees. Some months, it's like 0 rupees. That's what. Whatever you use, simply pay that. So elasticity, next thing is, one of the cloud feature is elasticity. Scale up, down automatically. For example, I told you only 5 applications, 5 different businesses are going a lot. So I can increase the capacity of 5 different applications anytime. Increase, decrease. That's what elasticity. You can increase the capacity of your application, decrease the application capacity. It's your wish. Again, minute based. So pay as you go consumption model. Any cloud provider nowadays, they are offering pay as you go. That is what so far I have explained. Pay as you go means pay only whatever you consumed. Simple. So decouple infrastructure management from the application delivery. So see, decouple in the sense you don't need to manage infrastructure management from application delivery will be removed. You no need to worry about the infrastructure. For example, blade server, rack, cluster, data center. You no need to worry whether power is there, whether network issues is there. For example, data center will be on earth, right? It will be in a place, maybe a cyclone, maybe earthquake, maybe a fire accident in the data center. You no need to worry anything. Simply you use, you pay, done. You can simply ignore the infrastructure management. That's what the meaning. So on-premises versus cloud, one more example, that if you see left-hand side, that is what on-premises. You're here for the responsibility of the customization and implementation of the data center, hardware, IT professionals, maintenance, training, everything, whatever you need to bear, and software and license cost you need to bear. If you see the cloud, other aspects will be managed by the cloud vendor. For example, Microsoft Azure, AWS, GCP, I mean Google Cloud Computing, right? Google Cloud Computing Platform, GCP. Those vendors will manage the data center. You don't need to worry about the data center first. Buy the subscription, pay only whatever been utilized. Simple method. So one more comparison. On premises, if you see, you have to manage right from the networking, storage, servers, virtualization, operating system, middleware, runtime, data, application. Whereas in the cloud, other three solutions, right, service types are from the cloud. Any cloud, you name any cloud, they have these three different varieties of services. Infrastructure as a service, platform as a service, software as a service. I'll give examples as well. So infrastructure as a service is nothing but just like your laptop, you are going to create a virtual machine there, server operating system. That's what I really mentioned, right? You don't need to worry about virtualization, but you can install directly operating system, whatever you want. Windows, Linux, Fedora, Ubuntu, CentOS, whatever. You can install it on top of that middleware, runtime, data, your choice of customization on top of that application. For example, irctc.com, and you expose that to internet. This is what infrastructure as service. If you want operating system, they'll give that. Okay, you don't want operating system as well. Only you want to manage data and application. Again, no problem. Platform as a service, you can simply create your platform as a service. For example, first one, infrastructure as a service, virtual machine is an example. Platform as a service, web app or app service is an example. Anyway, you don't need to understand about that now. So they provide web app and software as a service. Simply everything will be managed by vendor. For example, Office 365 or Gmail, right? What you do in the Gmail, you simply create your username and password, you utilize it. Same, software as a service. That's what three different varieties being offered by cloud, any major cloud provider, AWS, GCP, Azure. So major cloud providers, that's what we discussed so far. Microsoft Azure, Amazon Web Services, Google Cloud Platform, GCP. These are three major key players in cloud space. So for example, I'm concentrating on Azure Cloud as of now, right? So but because we can't complete all that three, I'm taking one example. So Azure Cloud Components, if you see, Azure, we discussed just before, Microsoft Azure Data Center is available in an ocean or sea, right? You're able to see underwater in my previous image. Like that, Microsoft Azure hosted 60 plus Azure regions, means 60 plus Azure locations, physical locations. Just like the is coming to Vizag, same thing, Azure having 60 different locations, their data center. Even in India, if you see, South India, Chennai, they hold the data center, Central India, West India, right? So different locations. US you can see, Brazil you can see, right? Germany you can see, different, even Australia, different locations, they hosted their data centers, and it's called as regions, different 60 plus regions. And one more very much important point here is largest of all cloud providers. We just discussed three major cloud providers, right? GCP, AWS, and Azure. Azure having very large footprint in regions. None of the cloud provider having this much capability. So regions, that's what we just discussed. What a region is look like. A region may have minimum 1, maximum 3 availability zones. So a region will have minimum 1, maximum 3 availability zones. What availability zone contain? Availability zone contains one or more data centers. We just discussed data centers. So each and every 60 plus regions, this is what Microsoft Azure having. A region is combination of zones. A zone is 1 kilometer far or 5 kilometer far or 10 kilometer, right? So within that radius, they host data centers. Why? Why this is really needed? For high availability. So if I host my application in availability zone 1, I will replicate that to availability zone 2. What is the benefit out of it? If availability zone 1 having a network issue, fire accident or earthquake, cyclone, whatever, my application still available from availability zone 2 or availability zone 3. Entire data center is fired, right? It catch fire, no problem. See, we are thinking about our safety, right? That's why we can host our application different zones and our application still available for my customer. Very much simple. So that's what. Availability zone in a region, maximum 3 availability zones will be there. Each zone will have one or more data centers. That's what the concept. So these are the regions and region pairs. Different locations, Azure regions located. So regions are okay. We are discussing about Microsoft Azure. So Azure having key components. Let us understand how Azure, while accessing the portal, when we are in a situation that to create application or virtual machine or different services in Azure, what we need to consider. If something really not understand, nothing to worry. I'm saying this point from the beginning. So, or if you feel anything doubt, ask me. Simple. So, management group is a component that a very root level, very top level service. It's not the service actually, very top level container which holds the below services. For example, under management group, you will have subscription. Under subscription, you will have resource groups. Under resource groups, you will have resources. So to understand how you plan your infrastructure in Azure cloud is, for example, if you see here, very top one corporate IT is a management group. Under that management group, for my convenience, I split into 3 different management groups under it: production, development, QA. Under production, I managed 3 different subscriptions. Each subscription, for example, mission critical, one subscription, protected data, other production, right? Only production related, I maintain 3 subscription. Each subscription will have its own application related resource groups. Application 1, application 2, application 3, 4, 5, 6. Same goes to the development, same goes to the QA. So this is about how we want to manage our infrastructure with ease of management, right? We need to design our infrastructure with very meaningful structure. Simple. And same different example. If you see, I have a business unit management group. Under that, geography based management groups. Under that, environment based management groups. Under that, subscription. Under that, different applications. Geography, for example, West Europe, North Europe. That's a geography. Under that, environment, production, non-production, QA, testing, whatever, right? That management groups. I mean, I'm trying to explain here, while you are here to manage the infrastructure of Microsoft Azure, you need to keep some key aspects of how to manage your infrastructure in a meaningful fashion. You need to split that in a meaningful fashion, and it is easy to manage as well. There are many deep points behind this why we split. That comes later, but for now, this is a hierarchy. So Azure services, that's what we are discussing. So there are more than 200 services are available in Microsoft Azure, different kind of services. As I explained, infrastructure as a service, platform as a service, software as a service. These three categories, more than 200 services are available with Microsoft Azure. For database, we have SQL database, data lake, and many. For example, cache, Azure Redis cache, and Azure database, right? For messaging, if you see, service bus, queue, storage queue, for example, event grid, and for example, to host web application, we have web apps and virtual machines to host your Windows or Linux applications, automations for the automation account. So different services are available, and you can manage that. Simple. So one more thing. Okay, if I start learning Microsoft Azure, whether I need to learn all these services, you need to have a overview, and I'll finally tell you why we are here. Then you will feel real ease. So this is what Azure portal. Simply you go there and create your storage account or virtual machine or a resource group, subscription, automation account, whatnot, anything. You simply create, manage, monitor your services in Azure portal if you chose Azure Cloud provider. So generally, what is Azure admin day to day? He review the alerts, logs, and performance dashboards. Right? If something goes wrong, he need to fix and manage the access. For example, users. For example, groups, permissions. For example, a new employee joined in our organization. He is going to join in our group. You have to create that user. You have to give him proper permissions. Right? That is one. And analyze cost usage, identify if anything unused resources, right? Think about cost saving measures as well, and deploy resources using Bicep, Terraform, CLI. This is very much important. Day to day, your 30% job or 40% job relies only in this particular point. Deploy resources using Bicep, Terraform, CLI. But trust me, deploy resources using Terraform is 90% you doing. In that 40%, 90% people doing using Terraform only. CLI is a rare case, Bicep, very rare case, right? So Bicep is alternative to Terraform. Microsoft created their own infrastructure as code thing, that is Bicep, but Terraform is universal. If you know Terraform, you will be able to work in AWS, you will be able to work in GCP, Azure, anywhere, even virtualization. That is what the power. Very easy one, very easy thing to manage. So deploy resources using Terraform, CLI, Bicep, and maintain automation runbooks and schedule tasks. Another, this is where you spend 20% of your day. So this is nothing but, see, a task came today, that is going to come tomorrow, day after tomorrow. What we do? We try to think, okay, why I can avoid this particular task. It's coming day to day, right? Okay, let us automate. That is what automation runbooks. We simply automate. If a task is coming more than once towards us, we simply use automation. Tomorrow, for example, my manager came and he asked, what is the cost of the Azure services this month? Okay, I sent this. Next month also he'll come, right? He'll come and ask, what is the cost? Then simply what I do, I automate the task And this particular task is capable to send an email to him as well. Whatever the text he wanted, it will write. Whatever the Excel sheet he wanted or PDF he wanted, it will prepare, attach, send him every month first. Very simple. So, like that. There are many automation possibilities which we can do. This is what your 20% time goes. Resolve tickets, incident, provide troubleshooting supports. Another 20%. So coordinate with the team for the deployment, maintenance, and updates and team calls. There will be calls you have to attend. So that's what, another 20%. This is what a typical Azure admin day-to-day lifestyle is. This is where he concentrating. This is what he doing. If somebody knows all this, then he is ready for the Azure administration. Yeah, sorry. Now, services in, just a comparison, just because we concentrated on Microsoft Azure, right? So why can't others as well, other services as well? So services comparison between AWS, Azure, GCP. We just discussed about virtual machines. What we call that? Just name change, concept is same. You need to remember one thing. If you know one cloud, other two clouds are pretty much easy for you. Remember this. So VMs, VM instances on GCP, easy to instances in AWS, right? So, for example, storage accounts, S3 buckets in AWS and cloud storage is GCP, right? So, like that, Kubernetes services. For the container orchestration service, that is container orchestration service. EKS, what called in AWS, and Kubernetes engine is called in GCP. So there are, again, comparison, if you take, there are a number of services, more than 150 services you can simply compare like this. I just kept a few. So like this, if you understand one particular cloud, only name changes, concept as it is. You can simply configure, manage, maintain, monitor any service if you know one particular cloud provider. Simple. So Azure versus AWS versus GCP, short comparison if you see. Strength. What is the strength of Azure is enterprise. It is enterprise level, company level, right? Hybrid and Windows workloads are very much strength there. AWS, large service catalog. There are a number of services are available. GCP is AML, innovation is most there. So global regions, we just discussed, more than 60 Azure regions are available, whereas AWS just 30, GCP is 20. So Azure is best for enterprise, DevOps, hybrid environments, and AWS is best for startups, cloud native services, whereas GCP is AI workloads or data workloads. Pricing is balanced when you see Azure, and AWS is complex, little bit complex, and GCP cheaper only for the compute. Other services are costly. So one more thing, if generally Azure is something like, if you know Windows very well, or if you're able to access your laptop a lot with the Windows operating system, Azure is easy for you. AWS is little bit CLI based, Linux friendly, kind of. Most of the service, not all. If you know Linux, you can easily get in with the AWS. GCP is ideal for both. So modern cloud use cases. We learned this, but we need to know what is the use case, right? So you can use the cloud computing for the AI, ML workloads, containerization, and container orchestration. For example, Kubernetes, serverless applications, DevOps and CI/CD pipelines to host their application in cloud, and big data pipelines and analytics services. This is where 90% of the cloud computing utilization. This is what the services. I mean, behind the scene, if you take AML, Azure having AML services, your duty is to just to deploy, manage, monitor. Same for the AWS, same for the GCP. And containerization, serverless, whatever, those are services. And very final thing, what you do is you simply create the services, maybe using Terraform, manual method, CLI, manually you click next and create the service. Using Terraform templates you create, right? And you reconfigure that, you manage that, you monitor that. Monitor if there are any issues, you are there to resolve. That's what a typical Azure engineer duty. Once you learn this, you're simply able to, once you complete all these topics, you're simply able to write AZ 900 Microsoft Azure Fundamentals exam. This is basic entry level exam. You can see the syllabus also, from where it comes, different areas. This is advanced AZ 104. Even architect level exams also there, which we are not going to cover now, but this is much more enough if a person want to survive in the Azure engineer position. So here, Microsoft Azure Administrator is an official advanced level certification. This is the syllabus. So by following the above content, so we can cover that as well. So that's what my side. So anyone having any doubt, anything on my content? Okay, then I'll hand over this to the Digit admin and he'll continue.